A vehicle is selected at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill its tank is more than 50.5 liters? What we need to find is the probability. So the answer that we are about to give is a probability. What is the probability? Before looking into the table, we will see if we can give a general idea of what a probability is. Probability is defined by the formula that we have there. Probability is equal to the number of events that will give a favorable outcome over the total number of equiprobable events. So if you just follow the words to say that this is probably too wordy, then you might be lost. But as a matter of fact, it's a very simple formula. Although it is simple, right here, mathematicians are making provision for further work in probability, and that I will explain in a few seconds. So we are going to take a look at the number, because the probability is the number of events that will give a favorable outcome over or divided by the total number of equiprobable events. So we need to know what we mean by number of events that will give a favorable outcome. Any vehicle whose tank needs more than 50.5 liters will give a favorable outcome. Why? Because the statement of the problem requires the probability that the volume of petrol needed will be more than 50.5 liters. More than. So any vehicle whose tank requires more than 50.5 liters, then that one is to be considered. And if it is to be considered, it is because it will give a favorable outcome. So any vehicle whose tank needs more than 50.5 liters will give a favorable outcome. The numerator will contain the number of those. So the numerator will contain the number of those that will give a favorable outcome, and those that will give a favorable outcome will be those whose tanks require more than 50.5 liters. Total number of equiprobable events. Total number of equiprobable events. And this is a very serious statement. It might not have so serious an implication at the moment, but surely for further work in probability, when probability theory becomes more sophisticated, we cannot just say the total number of events. We have to say the total number of equiprobable events. Why equiprobable? Because the number that we are talking about here, each of those events must have an equal chance of occurring. And that is why it has to be equiprobable. So we cannot total those events unless each one has an equal probability of being selected. And that is what we mean by equiprobable. That means any one is as likely to be selected as the other. All of the cars in the data set have an equal probability of being selected, or equal chance of being selected. The total number of cars will be the total number of equiprobable events. So the total number of cars. It just turns out that the total number of cars is the total of the cumulative frequency, which we have calculated already. So if it were not already calculated, we would have to calculate that. So the total frequency that we have here is 150. And that is actually the total number of equiprobable events. It's the total number of vehicles in the entire data set. And in the data set, we are on the assumption that each vehicle has an equal chance of being selected. And that is why it is equiprobable. So we have the total is the total number of equiprobable events. And it is the total of the frequencies, which turns out to be the final cumulative frequency value. Now, more than 50.5 liters. So we need those vehicles whose tank require more than 50.5 liters to fill. We are highlighting that. So we have to focus on the 50.5 liters because we need the total number of vehicles, first of all, which require more than 50.5 liters to fill the tank. And those will be the total number of events that will give a favorable outcome. So what we have done here is that we have already highlighted the first occurrence of 50.5 liters in the table. So we have 50.5 liters in the table right there. So we are looking at all of the vehicles whose tank require more than that number. So greater than 50.5. So there we have highlighted 50.5, the first occurrence of it in the table. And what do we know next? There is only one class. So we have only one class in which the volume required is more than 50.5 liters. How do we know that? We know that because 50.5 liters is the upper boundary of this class. And because it is the upper boundary of this class, then we know that inside of this class, there is no vehicle which requires more than 50.5, because the greatest value in this class in terms of volume required is 50.5. So inside of this class, all of the vehicles are between 40.5 and 50.5 liters in capacity for their tanks. So we are sure that although we have 50.5 here, right beside 50.5 we have 28. But 28 is not so much associated with 50.5. It is not so much associated with 50.5 because 50.5 is the end of the class. It is the upper boundary of the class. Inside of the class, which the interior of the class will be from 40.5 to 50.5. So this 28 is within that slot. So this 28 will not, there's no single item in this 28 or vehicle in this 28 whose tank requires more than 50.5, because 50.5 is the upper end of that class. Therefore, for a vehicle to require more than 50.5, it will have to be in the classes whose values are greater than 50.5. It turns out that there's only one class. So there's only one class that we have there, which is this one, with vehicles that require over 50.5 liters to fill their tank. Also, we need the number of vehicles which will be the total of the frequencies. So we need all of the frequencies in all of the classes that are greater than 50.5. But it turns out that it is only one class. So only one class. If it were many classes, then we would take a total of all of the frequencies. But in this particular case, there is only one class with one frequency. This should be divided by the total number of vehicles. And the total number of vehicles will be what? The total number of equiprobable events. And when we divide by 150, which is the total number of equiprobable events, we could just write that down. Or we could just take a look at it and realize that it can be simplified by a common factor of 3. So the fraction may be simplified by a common factor of 3. 3 into 150, 50 times. And of course 3 into 21, 7 times. So the final answer is 7 over 50, or we may say 7/50th. We don't want to say that. 7 over 50 might be acceptable at this point. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.